As an IT administrator, one of the realities you need to face each day is the threat of attacks not only from malicious users, but from malware like viruses and spyware and trojans and adware and so forth. Now, it's really gotten to the point whereby we need to ensure that our clients that connect to our network, they've got many different programs running just to try and prevent us from all getting infected with these nasty programs. So how does this stuff even get into our network? Well, there's many ways that malware can enter our network. So employees, they can simply visit bogus websites and they can get malware onto their computer that way. Now, maybe they're using pirate software. And of course, a lot of things like keygens. For these applications that people pirate, a lot of these will have viruses. They're going to have things like trojans. People can bring their infected notebook computers and PDAs and things like that. They can bring them from home, they can plug them into the corporate network, and they can spread malware that way. Now, it doesn't always have to be employees, though. Consultants or business partners, other people, they can bring in their notebooks and they can do exactly the same thing. So to protect ourselves, we need to be running antivirus software. We need to be running anti-spyware applications. We need to be running firewalls. We need to continually patch our software with the latest bug fixes and security fixes, and the list just keeps on growing. Now, as a responsible administrator, though, it's likely that you already run these sorts of applications in your network. But even though we have software in place to update our systems, what happens if these updates fail? Well, let's look at this. On most modern versions of Windows, through from Windows XP to Windows 7, we've got built into the operating system a firewall. Now, we also have a built-in anti-spyware application with Windows Vista and Windows 7. Of course, that's called Windows Defender. Now, Windows Defender, by the way, wasn't included with Windows XP by default. It was a separate download. It's free, of course, but it wasn't standard with XP. Now, Microsoft also included with Windows a program called Windows Update, and that allows us to update our computers, although in a corporate environment, we're much more likely to be using Windows Software Update services to update all of the computers in our network. Now, the only other thing we have at the top here is we have a requirement for antivirus, something that doesn't yet come standard with any version of Windows, but something that I wouldn't be surprised to see included with Windows at some time in the future. So, with all of these different mechanisms for updating our operating system, it's a surprise that there really isn't a way of verifying that our computers actually have all of these things up to date. Now look, if all things worked as intended, then Windows Update would automatically update our machines, Windows Defender would automatically update its signatures, our firewall here, that is always going to protect our computer, and of course any antivirus programs that we're running, they'd also be updated as well. Now, in a perfect world, all of this updating actually does happen. In the real world, it happens most of the time. But what if it doesn't? What happens if Windows won't update? Or what happens if your antivirus won't update? What then? Well, this is where NAP steps in. NAP, or Network Access Protection, is designed to check that your machines comply with an overall corporate health policy, a set of rules that determine what state you'll accept your machines to be in before they can access the network. So in other words, you could configure your health policy to only allow people to connect to your network if they have a firewall installed and it's active, if they've got anti-spyware protection installed and it's up to date, and if they have antivirus installed and that's up to date, and if they have the latest Windows updates installed as well. So NAP here, this is the technology that you can use to check the state of your clients. Are they up to date? Yes, well, then you can connect to our network. Are you up to date? No? Well, then you can only connect to a smaller subset, a restricted part of the network, until you decide to update yourself with the latest patches and signatures and, of course, turn that firewall on. So it's one thing to have antivirus and anti-spyware and Windows updates, but it's another thing to actually have your system up to date. NAP forces you to update your systems, and that is a good thing. Now, of course, there are times that computers just don't get updated, not because of problems exactly. When you consider things like notebook users can be away from the corporate network. Now, sometimes they mightn't directly connect to the corporate network for days on end. Maybe the user's on vacation. They come back, they plug into the network. Now, it's not that those machines will definitely have problems with malware. In fact, it's probably more likely not to be the case. However, any unpatched machine is still a risk. So again, it's NAP that can make sure that these machines are fully patched before being allowed to access all places in the corporate network. Now, the same goes for technologies like Hyper-V. Now, Hyper-V is such a popular tool, and with virtualization comes the likelihood that administrators will build machines, maybe for testing or development purposes, and they'll just shut them down when they're done with them. Maybe they'll turn them back on 2 or 3 months later. Now, those machines, of course, would be well out of date, and they would need updating to bring them in line with the current health policy. Okay, so in order to be able to take advantage of this NAP, this Network Access Protection feature, your operating systems must be running Windows XP with Service Pack 3, or a newer operating system like Windows Vista, Windows 7, and of course Windows Server 2008. So don't think that, by the way, this is only for client operating systems. Modern versions of Windows Server, they can also apply and be forced to comply with these NAP requirements. And by the way, if you are thinking of sitting the Windows 2008 Microsoft exams, you might want to remember which operating systems support NAP. So that's Windows XP with Service Pack 3, Vista, Windows 7, and Windows Server 2008. Now, one of the things you're going to quickly realize with NAP is that you're going to hear about a lot of new acronyms, things like Network Policy Servers, or NPS, Network Access Protection, or NAP, things like SHVs, SHAs, and more. So let's take time to discuss what these things are and how they all tie together, since it'll help to understand the actual configuration later on if we can visualize from above what all of the pieces of the jigsaw look like. Okay, so we can visualize what we're talking about here, let's do some drawing. So here we have the internet. Yeah, that's right, that's the whole internet right there. And obviously our network would be connected to the internet and separated by a firewall of some sort of description. Now, quite possibly, what we would have would be 2 firewalls here. So we could form some sort of perimeter network where we'd have a VPN server here, allowing internet clients the ability to gain access to our corporate network. And we'll say that's our corporate network over here. Now, inside our corporate network, we're going to have a lot of different servers running, but for the purposes of this discussion, we're only going to talk about the ones that we need. So things like SQL servers, Exchange servers, we're going to ignore those. But obviously, there are going to be some core infrastructure servers here. Things such as we're going to have an Active Directory server. We may have a health requirement server, and things like a network policy server. Now, when a user wants to log on to our corporate network here, they'll be scrutinized by a service called a NAP enforcement point. Now, this NAP enforcement point can be one of several different types. So users will attempt to gain access to our network either from outside the network, over the internet, using something like our VPN connection here. That's one type of NAP enforcement point, a VPN server. Maybe they're connecting using a wireless connection, or maybe they're hardwired to our network, and they're connecting using a typical Ethernet connection that supports IEEE 802.1x authentication. Now, in a lot of cases, they're going to be issued an IP address from our DHCP server. And there's also another NAP enforcement point called a Health Registration Authority, or an HRA. And that's simply a server that's running Windows 2008 and IIS, and it obtains health requirement certificates from a certificate authority for our NAP clients. So obviously, there's a few different ways that people can enter our network, but with all of these traps in place, the end result would be that one of them is going to pick up our logon attempt and it's going to check the client that's attempting to log onto our network against rules that are set by our network policy server. So here's our user. Let's say he's called Jordan. Jordan's going to attempt to log onto our network. Now let's say we're using DHCP to issue Jordan's computer with an IP address, which incidentally must be an IPv4 address. IPv6 isn't supported. That'll probably be sorted out sometime in the future, but right now, just in case you get that on the exam, this is an IPv4 thing only. So our user here, Jordan, he needs an IP address. The DHCP server, of course, is going to be, if we configure it, it's going to be a NAP enforcement point. So because Jordan's computer is configured as a NAP client, a component on Jordan's computer called the NAP enforcement client sends the DHCP server a system statement of health, an SSOH, which is basically a summary of all of its patches, all of its versions of definitions, and the things that the server will want to know. So let's just sidestep here for a moment. I want to talk more about this system statement of health, this SSOH, because it is important. Okay, so let's just say that this is our typical user's PC here. Now we know that each NAP enforcement client, which is simply our PC really here, or our workstations, etc., on each client is going to be some sort of agent. An agent called the System Health Agent, or just SHA. Just think of this as a service that runs on the client. Now, contrary to popular belief, there can be different types of these System Health Agent. There's a Windows System Health Agent. There's a System Center Configuration Manager System Health Agent. There's even a Forefront Client Security System Health Agent. And since Microsoft released the APIs for NAP, you're going to find that there's other third-party security type products supporting it, and therefore you'll see there's a lot more than these few. For example, Symantec, we've got Kaspersky, McAfee, and others. They all create them to ensure that their applications can be included in the system health validation process. But for now, understand that it's simply this SHA, this system health agent, that creates a statement of health. So we already know that there's several different types of health indicators that a client must meet in order to pass the overall health check. Now this can include things like antivirus, anti-spyware, we've got Windows updates, and of course, a firewall. So the NAP client is going to check each of these things, and it's going to produce a statement of health for each of them. So each statement of health is going to detail the exact version of the software that the client has installed. So we're going to have one statement of health here showing us what version of antivirus we have and what definitions we have. Our next statement of health will detail everything here about our anti-spyware product that we're running, the same for our Windows updates, and the same for our firewall. Now each time we update any of these components, for example, let's say we download and we install a new Windows update patch, then the NAP client is going to write out a brand new statement of health detailing what version of these patches it has. So when it needs to log on, it can send the latest information to the required servers. So these statements of health, they're all bundled up into one system statement of health. A kind of master file, if you like, that contains all of the various components and where they're all at with regards to their updates. So back to our network diagram here. Now that we understand what this SSOH or System Statement of Health is, our client sends this to the NAP enforcement point, which in this example, of course, is our DHCP server. Our DHCP server then sends this System Statement of Health over to the Network Health Policy server, which is installed on the Network Policy server, or this NPS server you see here. Now this server is going to take a look at the System Statement of Health that Jordan's PC here just sent, and it's going to compare it against the list of things that the PC needs to have. This is called the System Health Validator, or SHV. So where does this SHV get its requirements from? Well, it comes from the Health Requirements Server, a centralized location used for storing the health policy requirements. Now, even though I've listed it here, by the way, as a separate server, it can actually be installed on the same server as the network policy server if you like. At the end of the day, it's just going to come down to how busy that server is. So once this server has compared the SSOH with its list, the results are then going to be sent back to the DHCP server. And depending on whether Jordan's PC here passed or failed the health policy, his machine is going to be issued with an IP address. Now, if Jordan's PC fails the health check, let's say he doesn't have antivirus installed, then the DHCP server, it's going to tell Jordan's PC, hey, you don't have antivirus on your computer, therefore you fail our health check, so I'm going to give you this IP address and I'm going to send you off over here to a restricted network. Now, this restricted network, by the way, would then be a separate network that either has no routes to the corporate network or perhaps it's on its own separate VLAN. So on this restricted network, there would be a server called a remediation server. Actually, there might be more than one server providing updates, but the point is that this remediation server's job is to try and bring Jordan's PC here, which is known as a NAP client. The remediation server's job is to try and bring this NAP client back up to par by helping it get the latest updates, the latest antivirus software, etc., to make this computer up to date. So this remediation server would likely be running something like Windows software update services, which of course can help provide these patches to our NAP client. So once all of these updates have been applied to our NAP client, it's then going to update its own system statement of health. It's then going to contact the DHCP server again, and it's going to present it with its brand new copy of its system statement of health, and it's ready to be scrutinized again. Now this time, if it's up to date, it will then be allowed onto the corporate network. Okay, so that's Jordan's story, but what about another user? Let's say we've got a user here called Lucas. Well, again, his PC needs an IP address as well, and his machine's configured as a NAP client. So just like Jordan's PC does, Lucas's is also going to send the DHCP server a copy of its own system statement of health. Now the DHCP server again is going to send this system statement of health over to the NAP health policy server. This server is going to compare that system statement of health against the list of things that it knows that a healthy machine should have. And again, these results are going to be sent back to our DHCP server, which is then going to dish out an IP address based on the results of the health check. So if Lucas's computer here has met all of the health checks, the DHCP server says, good job Lucas, here's a shiny new IP address for you to use, and you can now log on to the corporate network, enjoy your stay. But just remember though, that this is how NAP would work in the event that DHCP was being used as the NAP enforcement point. If we were using a VPN connection instead, now things would work slightly differently, only subtly though, whereby the VPN user's connection would need to be authenticated first before even bothering with presenting the system statement of health. So if authentication succeeds, only then will the SSOH be sent to see if the connecting computer actually complies with the overall health policy. Now, since this has been a pretty long introduction to how network access protection works, we're going to leave it there, and we'll actually see how we can configure the practical side of NAP in later videos. There's a lot of different ways to configure NAP, and if we talk about all those different methods in this video, it's just going to blow out to be a huge discussion. Now, NAP on the surface seems pretty complicated. Actually, it's not all that difficult, but newcomers might be scratching their heads with all these new acronyms to remember. But that said though, NAP is one of those technologies that is worth investing some time into. Remember, NAP isn't designed to protect networks from malicious users. It won't stop a user in your network from doing the wrong thing. But by forcing your computers to comply with applying all of the latest security patches, it will make your network a much harder target for these malicious users. So we hope you've enjoyed this video and would like to thank you for watching.